Have you ever noticed how a master turner can step up to a lathe and magically he creates this finished product? I mean, everything is so smooth, so easy, and then you go home. And you try to do the same project, and what you discover is you fail, it breaks, you have a catch, and everything just seems to go wrong, and you say, what am I doing? Well, the answer is many times just the little stuff. And the fact that what happens to wood turners is that we don't really get exposed to all of the various skill sets that you need to have understood to make things easy for you as a master turner has. So this is another session where we're going to focus on one of those things that you need in your toolbox, which is how to drill safely and efficiently on the lathe. This is the first of 3 sessions. If you find this worthwhile or this endeavor to actually put onto a video specific skills for a wood turner, please do give me a thumbs up and join my channel. It can be encouraged to keep going with that session. Okay, so we're going to talk about drilling. First session is going to be about sharpening your drill bit. That's the basic of any drilling function on the lathe. The second section, we're going to cover about how to set up your lathe to drill safely and effectively and easily. And in the third session, once we've mastered all the basics, we're going to go through a series of specific drilling techniques that you will need to have at various times as you turn. Okay, we're going to start with how to sharpen your drill bit. Now it has, and then we're going to work on backwards on through the drilling column. You know, we all get taught very early on as wood turners how to sharpen our tools. You know, bowl gouge needs to be sharp. I mean, it just makes a tremendous difference, and we understand that when we're using our wood turning tools. But the amazing thing is, nobody ever drums into us or shows us even how to sharpen our drill bits. And yet that edge just takes as many miles of abuse as a bowl gouge does. And both of them are typically made out of high-speed steel, but nobody says to us, sharpen your drill bit, sharpen your drill bit. So the first thing we're going to show you is how to sharpen your drill bit. Now, you need to have some knowledge of the signs to look for that tells you it's time to stop drilling, stop turning, and go and sharpen your drill bits. First sign of a dull bit is when you have an urge to turn up that speed as you drill. That's probably indicative of the fact that you have a dull bit. Typically, Foster bits or recommended RPM is somewhere between 400 to 700 RPM, depending on the diameter of the bit. But if you have that urge, it's a sign that you need to stop, take a minute, sharpen your drill bits. If you find yourself wanting to go up to the tailstock and crank harder and harder and harder so you can get that bit to actually cut into some wood, guys, your drill bit's dull. That's what it is. Now, the other thing that's really important is smoke or steam that comes out of your drill hole. What happens is a dull bit creates more heat as it removes wood, and that's what you're seeing as you begin to see smoke and steam come out of your hole. So let's get specific. Okay, where we're going to start is what the specific tools that you need, and they're kind of simple, truthfully. All right, what we're going to need is a diamond card. I particularly like this one by Woodcut. It's a 400 grit on one side and a 600 grit on the second side. So on one card, I have both grits that I would typically use. Second thing you're going to need is a ceramic sharpening rod. The ceramic rods are color coded. The white is the finer grit. The green is a coarser grit. The white is the appropriate one, the fine grit. And then we're going to need a drill bit. This is a very typical drill bit. Now, if you look closely at this drill bit, what you're going to see, you see that blue and that black in there? That's a sign that this bit was abused, that the RPMs were probably too high, the bit was dull, and basically the amount of heat generated by that combination is just ungodly. So we're going to go ahead and sharpen it, and it probably the metal has probably been heated to the point that it won't last all that long. But it's good for what we're doing here, which is showing how to properly sharpen. So we're going to take the 600 grit side. We're going to come up to the main cutters that cut the bottom of the hole. We're going to find the flat, and we're going to go 1, 2, 3, 4, 5. You don't have to press hard. Just allow the card to do the cutting. You don't have to force. Now, if you notice, the first time I did that, I counted to 5. And this side, I'm going to go 1, 2, 3, 4, 5. There's a reason for that. If you remove metal on this side in a different amount than this side, your bit will have a tendency to go off track because the two sides are not the same. So do the same number here as you do over here. Now with that done, we're going to take the ceramic rod and we're going to go to the next cutting surface that's important to us, which is right here. Now that surface in there has a slight curve to it. So we're going to use the end of the ceramic rod and we're going to go 1, 2, 3, 4, 5. Going to go over to the other side and go 1, 2, 3, 4, 5. Now we've sharpened that cutter on both sides. So now the last thing we're going to do with this bit is take the ceramic rod and we're going to clean up this edge by just very slowly coming around and making sure that that is a crisp edge. And we're done. Now, I don't know how long that took me, but guys, I got to tell you, it's an unbelievable amount of difference. Now, what I have found is that after sharpening like this about a dozen times, it doesn't seem to get quite as sharp. And it took me a while to figure out what was happening. But what has a tendency to occur is because you're holding it by hand, you go off slightly. So after a while, if the sharpening doesn't work, the important thing to do is to take your bit, put it in a vise where it's held securely. And now we can come back up with our diamond card and we can use both hands to go in there and go 1, 2, 3, 4, 5. Now, sometimes let me back up. Truthfully, when that happens, you'll notice here that it's the 400 side. It's the coarser side because I want to remove a little bit more metal to clean up that angle. And once I've done that, 1, 2, 3, 4, 5. Now I'm going to turn the bit over, go back to my 400 grit. 1, 2, 3, 4, 5. Come in with a 600 grit. 1, 2, 3, 4, 5. Okay, so you clean it up, reset it by using both hands with the bit held firmly. Now, that's not the only configuration out there. This is another type of configuration you'll frequently see, which is kind of a sawtooth pattern on the bottom. So we have to address this slightly differently. Easiest way to do it is to use this, which is a triangular diamond file. And we're going to do basically the same thing. We're going to come back in and we're going to find the angle and touch that up and go around, go around, go around, and then come back with the bottom cutter right in here the same way, which is the 1, 2, 3, 4, 5. Done. Okay, now, carbide bits are another case, and carbide bits, they hold the edge longer, but they're never as sharp as a high-speed steel is. But they still need to be sharpened periodically. But if you look closely at them, it's basically the same configuration in that you have a main bottom cutter right here, which we can take the 600 grit card, come up, find the angle, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now, this particular cutter is really important. It really is important, particularly that leading edge, but it's a little hard because there's not enough material there to be able to ride the bevel, so to speak. So what I'm going to do instead is take the ceramic rod and I'm going to go to the outside and keeping it flat against the side, just go ahead and dress that cutter from the side. Bingo, we're done. Now, I've covered 3 different drill bits, but there's a lot of different configurations out there. So I would really strongly suggest that you contact the manufacturer of your specific bits to make sure that you have instructions from them how to correctly sharpen that specific geometry of a bit. I hope that helps you, because it does make a tremendous, tremendous difference. I think the next thing that I want to talk about is right here, which is drilling speed. Now, this chart typically is right by my lathe up high where I can look up and see it. And I know you may not be able to read it all that well, but what it has is hardwoods, softwoods, bit size, maximum RPM. And you can see that in what we typically deal with, which is a hardwood, the maximum RPM on a 3/8 inch bit is 1,000 RPM, 900 at a half, but it drops down to, on a 2-inch, to 400 RPM. On a softwood, the speeds are typically a little bit higher. Now, this will, again, vary from bit to bit, depending upon the geometry of the bit and the materials that the bits are made of, but I would strongly suggest that it is wise to reach out to the manufacturer and ask them that they give you specific information about recommended RPMs of drilling speeds for their particular geometry. Okay, now we've got a sharp bit, so we're going to start working back through the drilling column. And the next section, we're going to deal with drill bit selection, a repair of your Morse taper, explain what a Morse taper is, and also go through preparing your lathe for the actual drilling operation. Again, give me a thumbs up if you found this worthwhile, and see you on session 2.